Welcome to the next unit of PreCal. So what we're going to be doing today is taking our inverse trig functions that we did last unit and take it a little bit further. And that's what we always do when we're talking about PreCal. So when we talk about inverse functions, I want you to think about your rainbow. So our side rainbow here is sine inverse, cosecant inverse, or tan inverse. And then our top rainbow are cosine inverse, secant inverse, and cotangent inverse. So we're going to use that and not talk about the unit circle, but talk about triangles in the coordinate plane. So it is going to be important which trig function we're talking about and where we put that triangle. All right, so let's look at number one. So remember that when we're doing inverse trig, we're always finding an angle measure. Well, in this case, since 3/5 is not on my unit circle, I cannot find an exact angle measure for that. I can type it into the calculator and get an approximate angle, but I don't know what exactly it is. So in this case, I'm just going to put theta. Just give it a symbol or symbol and kind of figure out what we can do from there. So sine inverse of 3/5 is going to find an angle measure. Since we're doing sine inverse, that's our side rainbow. And since it's positive, means that I have a triangle in quadrant 1. So this is where my angle is going to be. Well, since we're doing sine, 3 is our opposite side, and 5 is my hypotenuse. I could honestly say this is 3/5 and this is 1, but it's easier to do this because then I can do Pythagorean theorem or know your triples and figure out what this side length is, which is 4. So then the question is, since I figured out what this angle measure is what is tangent of that angle? Well, tangent is opposite over adjacent, so 3/4. So my final answer would be 3/4. I could have done this on the unit circle, given you like root 3 over 2, and then find out what angle measure gives you root 3 over 2, like same kind of situation like that. But in this case, we asked you for what angle gives us sine inverse of 3/5, which is this angle here, which I don't have to find out what the measure is, because all I'm going to do is figure out what tangent of that angle is, which is 3/4. So let's look at number 2. This arctan of negative 3/4, this thing inside of here, since it's asking for arctan, is just asking for the angle. Arc and inverse are the exact same question. I could have put tan to the little -1 or tan inverse of negative 3/4 and get the exact same thing. So since tangent is our side rainbow and it's negative, our triangle is going to be in quadrant 4. So this is where theta is going to be. So tangent is either y over x or opposite over adjacent. So this is 3 and this is 4. But one of them has to be negative. Well, if you go to the right, then that's positive. If you go down, that's negative. And then again, you know your triples or do Pythagorean theorem and end up getting that that's 5. So this arctan of negative 3/4 gives us this angle measure. Could put it in the calculator, get an approximate thing. But really the question is, what is cosine of that angle? Well, cosine is the adjacent side over the hypotenuse, so 4/5. So be careful with your negative signs, just like what we did back in Unit 1. What about 1/2? I could draw a triangle where the opposite side is 1 and the hypotenuse is 2, but this is a unit circle value. 3/4 and 3/5 are not on the unit circle, but 1/2 actually is. So if I ask you what is sine inverse of 1/2, you should be able to tell me that's pi over 6. That's the angle in which our y value is 1/2. Again, using our side rainbow, positive values are in quadrant 1, so pi over 6. So then the question is, what is sine of pi over 6? Well, that goes back to 1/2. This doesn't always happen for every single question. It might change the sign in which your inverses are different and all that. So they don't just cancel each other off. In this case, they do, but not in all cases. So don't just see sine inverse, and cancel it off, because that doesn't always happen. Go through the steps. Sine inverse of 1/2 is pi over 6. What is sine of pi over 6? 1/2. So let's look at this next one. So we're going to do sine inverse. Again, that finds me an angle measure. And since it's sine inverse and it's negative, our triangle is in quadrant 4, where here's theta. So our opposite side is 3, our hypotenuse is 5. The hypotenuse is never negative, and we're also going down here, so that's negative 3/5. And then this ends up being 4. So what is tangent of that angle of the triangle that we got here? Well, it's opposite over adjacent, so negative 3/4. Again, negative 3/5 is not on the unit circle, so I can't just figure out a unit circle value. I need to draw a triangle. What about cotangent inverse of negative 15/8? Well, cotangent is the top rainbow, and since it's negative, our triangle is going to be in quadrant 2. So this is where that angle that we get from doing cotangent inverse of negative 15/8. So cotangent is a reciprocal of tangent. So tangent's TOA, so opposite over adjacent. So this is adjacent over opposite, or x over y. But then one of these has to be negative. You're going up here, so that has to stay positive, and this is going to the left, so that's negative. So what is cosine of that angle? Well, I need the hypotenuse. This is a triple, 8, 15, 17. So the adjacent side over the hypotenuse is negative 15/17. Secant inverse. Secant is the top rainbow. So I'm going to draw a triangle here. It gives me this angle measure. You don't have to draw that every single time, but just helpful for notes that this is giving me an angle measure, but I don't need to know exactly what it is. So secant is a reciprocal of cosine, so I can think about this as the hypotenuse and this as the adjacent side. So since we're going to the left, that's negative 3. The hypotenuse is always positive, and then the adjacent side would be 4, or the opposite side would be 4. So what is sine of that angle? What's the opposite side? 4 over the hypotenuse, 5. And again, leave your answers exact. Leave them in fraction form, but just easier. You don't have to take any step further. This is not 0.75. It is just 4/5. Ooh, what about arc secant of negative 6? Well, it is helpful to realize that that's negative 6 over 1. And then also that this gives me an angle measure. So since we're talking about secant, secant is a top rainbow. Since it's negative, it's in quadrant 2. If it was positive, it would always be in quadrant 1. So we put some negative ones on here. So same thing like the last problem, I can treat this as the hypotenuse and this is the adjacent side. The hypotenuse is never negative and the adjacent side is going to the left, so that's negative 1. So is this a triple? No, it's not. So you have to do some Pythagorean theorem. So it doesn't matter what this is, I'll just call it y since it's going up, plus negative 1 squared equals 6 squared. So you get y squared equal, or plus 1, I'll do all my steps, equals 36. So y squared equals 35. So we square root that. Does it simplify? No. So this is root 35. So then the question is, what is cosecant of this angle measure? Well, cosecant is the reciprocal of sine. So sine would have been root 35 over 6 because this is where my angle is. But in this case, it's 6 over root 35, which we can't have, so 6 root 35 over 35. That's something easy you can do. You can rationalize the denominator with. If it was something more complicated, like what we might see here in a bit, then you don't have to rationalize. But in this case, it's pretty simple, straightforward, so you could definitely do it that way. All right, so secant of tan inverse of 3x. So again, this inverse always tells me an angle measure. No matter what is inside of it, what it is, like it, as long as it's inverse or arc, you find an angle measure. So since we're dealing with tangent inverse, that's the side rainbow, and we're assuming x is positive, that's safe to assume that this ends up being positive 3x. So that's in quadrant 1. Anytime you're given inverse or arc of any positive value, it's automatically in quadrant 1. Well, tangent, you can think about as y over x, or opposite over adjacent of this angle here. It would be 3x over, well, everything is divisible by 1, so this is 1. So then we have to do some Pythagorean theorem to figure out what my radius is, or my hypotenuse. So I'll just put r squared, since we're in pre-cal and that's now our radius. And then do 1 squared plus 3x squared. So this is where a couple people have problems with, because what they do is that they square the 3, or square the x, really, and that's it. So they put 3x squared. But it's actually supposed to be 9x squared. And when you square root that, that ends up being your hypotenuse. You could put 9x squared plus 1 inside. That doesn't matter. But if it was subtraction, that order does matter. In this case, it doesn't. So what is secant of that angle? Well, secant is a reciprocal of cosine. Cosine is 1 over that. So that means it's square root of 1 plus 9x squared over 1, which I don't need the over 1. So that's my answer. You could put over 1 if you want to, but who needs it? All right, what about this next one? Well, cotangent, arc cotangent tells me an angle measure. And it's positive, so it's going to automatically be in quadrant 1. Well, cotangent is, you can think about it as x over y. So this is 1, this is x. And if you do all the Pythagorean theorem again, just like what we did over here, we end up getting 1 plus x squared, or x squared plus 1. Well, what's nice is that in this problem, you didn't really need that hypotenuse, because we're just going back to tangent, which is the opposite over the adjacent. So just x over 1, or simply just x. So draw the triangle out. It's very helpful. Do Pythagorean theorem. It is very helpful on practicing what you need to do for this unit. Now, this is where I get a lot of students that are trying to draw triangles. Tangent is not asking for an angle measure. Tangent is asking for what is the y over x at 3 pi over 4. Tangent of 3 pi over 4, that's a unit circle question. Okay, this is on the unit circle. And it's asking for what is y over x at 3 pi over 4. Well, 3 pi over 4, it's root 2 over 2, negative root 2 over 2. So if you divide that, you end up getting negative 1. So tangent of 3 pi over 4 is negative 1. It is not a triangle in the coordinate plane. It is just a unit circle question. So since we figured out the inside, now we can figure out what is arc cosine at negative 1. So this is asking you, what is the angle? What angle gives us the next value at negative 1? Well, next value of negative 1 goes to the left one, and that ends up being pi. So remember, in this class, if you're doing arc or inverses, just you leave it in radians. Don't change it to degrees. Don't tell me it's 180 degrees. Leave it in radians. Number 11 is another unit circle question, 4 pi over 3, and it's cosine of that. So it's just asking what is x at 4 pi over 3. This is a question where some people are just going to try to cross this out and just leave me as 4 pi over 3 as an answer. And that's not going to happen here. So 4 pi over 3, again, is a unit circle angle, and I'm looking for the x value there. Well, what x value is at 4 pi over 3? Well, that's negative 1/2. Because you're going to the left and down, so it's the point negative 1/2, negative root 3 over 2. So cosine at 4 pi over 3 is negative 1/2. Then the question is, what is cosine inverse of negative 1/2? Now, cosine inverse deals with the top rainbow. 4 pi over 3 is in quadrant 3. If I'm doing cosine inverse, my angle needs to be over here in quadrant 2. And where is cosine negative 1/2 in quadrant 2? Well, 2 pi over 3. So understand that these cosines don't cancel off, and you're left with 4 pi over 3. Your full answer that you're supposed to get for this is 2 pi over 3 based on our rainbow values. All right, last but not least, let's look at this one here. So again, this is just cosine of negative 2 pi over 3. This is asking what is the x value at negative 2 pi over 3. Well, negative 2 pi over 3 is really the same thing as 4 pi over 3. It's in quadrant 3, just 2 pi over 3 to the clockwise. So quadrant 3. So cosine at negative 2 pi over 3 is just negative a half. That's what the inside is. Then we're asking what angle gives us arc sine is negative a half. Well, arc sine or sine inverse are the side rainbow. And since it's a negative 1/2, it's down here. So where down there is our y value negative a half? Well, negative pi over 6. Not 11 pi over 6, but a negative 11 pi over 6 because our range has to be from negative a half to a positive a half. So these are inverse trig functions, sometimes on the unit circle, sometimes not. So you have to be able to decipher which one's which. So with these types of problems, you need to be very careful on knowing your unit circle question or unit circle exact values. Okay. In number 11, we had the same denominator. In number 12, we did not. We both had cosine here, and we switched from sine to cosine here. So pay attention to what you're doing. Pay attention to when you draw triangles in the coordinate plane and when you don't. All right, and welcome back. So what we're going to be doing today is solving sine and cosecant equations. So we're going to kind of see why we chose to graph or write equations of cosine graphs and use that to solve our intersection points. So remember that when we were using cosine, all we did was do like a plus or minus in front of whatever we got for cosine inverse. Like we put something in cosine inverse and we put plus or minus in front of it to make it easier, because that would make this equation so much better. Well, with sine and cosecant, when we were asking you like what are all the answers on like for sine and cosecant, what we would do is we would have a rainbow value, and I'm just going to use RV for that, and its supplement. So the rainbow value is either x or theta, depending on if we're in radians or degrees. And then the supplement is in radians pi minus that, or 180 degrees minus the theta. And it always has to be in that order. That's how we find the supplement. So notice in the directions that we ask you to either solve for theta in between this range. Notice that it's including negative 360, but not including 720. And then the same thing for radians from negative 2 pi to 4 pi, not including 4 pi. So pay attention to what variable that we're using. Theta is degrees and x is radians. So notice here it's theta. So we're going to put this in degrees. So let's solve this for theta. Well, the first thing that we need to do is isolate sine. So what I'm going to do is add the 7 over and divide by 14 on both sides. Well, instead of writing 7 over 14, I'm going to simplify that to 1/2. So our process from here is to get theta by itself is we inverse that function. So inverse sine both sides, and we get inverse of 1/2. Well, what's the rainbow value for sine being 1/2? Well, that's 30 degrees. So again, this is what we call our rainbow value. So we're going to have some general solutions. So our general solutions, and this is something that you need to make sure that you have in every single one of your problems, is that theta equals that rainbow value plus some period length n. And in this case, we're just talking about sine, so 360. And its supplement. So 180 minus 30 is 150. And we still add that 360n. So our two general solutions have to deal with the rainbow value and its supplement plus the period length n. So this is the reason why we didn't use equations using sine. We use cosine. Because for cosine, we just put a plus or minus in front of the rainbow value. For sine, we have two completely different general solutions. So we would have to write them separately instead of putting a plus or minus. So then we need to figure out all the solutions where this is equal to 0 within my range, because these give us the infinite number of solutions for this equation. And what we want is we want the specific ones within this range. So what we're going to do is add and subtract multiples of 360 from that. Order doesn't matter on this. What I always like to do is start with the rainbow value and then do minus 360. Can't do any more than that because then it's out of my range. And then add 360. And then I can't add any more 360s because that would go out of my range. So then I do 150, subtract 360, and then add 360. And those are the 6 solutions for this equation within the range of negative 360 and 720. So again, on your own, you could be adding and subtracting 360 to kind of see why I stopped here and stopped here, as well as the negative ones there. Again, you can put these in any order. It doesn't really matter as long as all the solutions are there.
So for this next problem, we have cosecant theta plus root 2 equals 0. So I'm going to solve for the trig function by subtracting the root 2 on both sides. And we could inverse cosecant both sides, but some people don't know what the cosecant inverse of negative root 2 is. But if I do the reciprocal, I get 1 over root 2, which is the same thing as root 2 over 2, which everybody should know. If I do the inverse sign on both sides, the rainbow value for negative root 2 over 2 is going to be in degrees, negative 45 degrees. Then the rainbow, or the supplement for that, because we're doing a sine inverse, the supplement of negative 45 degrees is 180 minus negative 45, which ends up being 225. So those are our two values from negative 360 to positive 360, or my rainbow value supplement that I do for inverse trig. But since we're trying to solve this, we need to write general equations. So I'm going to add a period length times n to the negative 45. And then I need to do the same thing for the 225. And I should always have general solutions. It's just a good practice. So general solutions are equations, so make sure that they're theta equals. Then you can figure out all the answers within the range or interval of answers that we have from negative 360 to positive 720. And I'm just going to list them out from least to greatest. 225, 315, 585, and then lastly 675. This next problem is very similar to the last problem. I'm going to subtract the root 3 on both sides, multiply both sides by the reciprocal of 3 halves, which is 2/3. So you end up getting negative 2 root 3 over 3. Which again, you can inverse cosecant both sides, but something that everybody should know is if I do the reciprocal of this, the reciprocal of negative 2 root 3 over 3 ends up being negative root 3 over 2. So therefore, everybody should know that if I inverse sine both sides and ask you for the rainbow value of negative root 3 over 2, and we're doing theta, so it's in degrees, you should give me negative 60 degrees. And the supplement of that is 180 minus negative 60, which ends up being 1 plus 60, so 240. Which again, I need general solution, so add a period length n, add a period length n, and make sure that both of them are actual equations. And then we find all the answers from, or within the interval of answers that we get, and you can write them in order from least to greatest. You don't have to. We get negative 120, negative 60, 240, 300, then 600, and 660.
All right, so look at the next one here. We're not multiplying theta by something, but we are adding 13 degrees to this. So we are doing theta, so theta is degrees, and we didn't tell you a different range, so we're staying between negative 360 and 720. So let's do some algebra. This 2 is on the outside of sine, so that's okay to just divide both sides by 2. And you end up getting negative root 3 over 2. Well, just like what I talked about in the last problem, there's no way of getting this 13 outside of sine unless we get rid of sine. And the way that we get rid of sine is by doing the inverse function on both sides. So then this is where I write my general solutions. So like I did on the last one, it was 3 theta. This time it's theta plus 13 degrees. Well, what's the rainbow value for sine inverse being negative root 3 over 2? Well, that's negative 60 degrees. And then the supplement of that would be 180 minus negative 60, so 240. So these are almost my two general solutions. What I need to do is solve it for theta. And this is where students forget their algebra. I need to subtract negative 13 degrees on this side, and then I need to subtract it on this side. Well, the only like term for negative 13 degrees without an n is negative 60. You cannot add to n unless you have an n. So this same thing happens over here. So our general solutions end up being theta equals negative 73 degrees plus 360n, and theta equals 227 degrees plus 360n. So these are my two official general solutions of theta for this equation. Now, understand there might be times where this is on a non-calculator part of a quiz or test. This was on a calculator part. So you should be able to add and subtract 360 from here to get our six answers for this range as well as equation. So we end up getting these. So again, what I did is I started off with negative 73 and then couldn't subtract 360 to stay in my range, but added 360 to keep going from there. And then the same thing happens for 227. If I subtract 360 and add 360, I get these answers. So just make sure that you know how to do arithmetic for these types of problems.
In your notes, you should have sine squared of x equals 1. Now, the reason why it's this type of problem instead of just sine of x is because we want to make sure that you understand something very particular about this problem. And that's if we square root both sides to get rid of the squared, you end up getting sine of x doesn't just equal 1, but it also equals positive 1. So this is solving two different equations. We're going to solve where sine of x equals 1 and where sine of x equals negative 1. So what I'm going to do is I'm going to kind of break that up and do sine inverse of positive 1. And then I'm going to do sine inverse of negative 1. So if I ask you for the rainbow value of sine is 1, well, where on the unit circle is the y value 1? Well, that's pi over 2. And we're doing radians since we're dealing with x, and x is, in the interval of answers is in between negative 2 pi and 4 pi. So if I do the supplement, or if I ask you for the supplement of pi over 2, it's pi minus pi over 2, which is the exact same thing. So really, this only has one answer for positive 1. But then, if I ask you for the rainbow value of negative 1, you should tell me it's negative pi over 2. And if I ask you for the supplement of that, pi minus negative pi over 2 ends up being 3 pi over 2, which is the same answer. So really, this is the only general solution I have for when sine is negative 1. So then I need to just list out all of my answers. So for this general solution, we end up getting negative 3 pi over 2, pi over 2, and 5 pi over 2 within the interval of answers that they want for x. But then over here on the sine inverse of negative 1 part, we have negative pi over 2 as the smallest angle that we have within the interval, then 3 pi over 2, and then 7 pi over 2.
What about this next one? Wait, secant is not sine or cosine, or cosecant, sorry. It is cosine, actually. It's the reciprocal of cosine. So if you were to solve this, we get secant of x equals to 2, and some people can inverse that and find out what the rainbow value is. The majority of people like to see the original trig function, cosine. So if secant equals 2, then cosine equals a half. So we end up doing cosine inverse of 1/2. Again, we could have done secant inverse, that's fine. This is actually on the unit circle, so you should be able to do this without a calculator. So since this is x in radians, I'm going to get my rainbow value to be positive pi over 3. Well, since we're using cosine, this is when you need to know what method you're doing. Cosine is plus or minus the rainbow value plus our period length n. So you could write this general solution into two equations, positive pi over 3 plus 2 pi n and negative pi over 3 plus 2 pi n, or just put a plus or minus in front of the rainbow value. And then you find all your solutions. So we end up getting 6 solutions for this, and we're done. Now, some of y'all might notice that, oh, well, couldn't I do plus or minus pi over 3 and plus or minus 5 pi over 3? Yes, you could have. Now, when I was listing these out, I didn't notice that, so I just wrote them out like this. But in your own work, if you realize that, you can put plus or minus in there. So if you have any questions, please let me know. If you need to work out any of the equations in your homework in class, that's what class time is for. So please ask about those. Have fun.